Hey, good morning, everybody. This is Mr. Aynesworth, and we're going to get into mastery number 8 on how to solve equations graphically and algebraically. All right, so let's get right into it. We got 3 to do here in this mastery. We're going to take 2 cosine x minus 1 equals 0, and we're going to solve for all solutions on the interval from 0 to 2 pi, okay, where x can be greater than 0 and less than or equal to 2 pi, anywhere in that interval. All right, so let's take the equation off to the side. Here we go. So 2 cosine x minus 1 equals 0. We're going to isolate the function by adding 1. So 2 times cosine x is equal to 1. Divide both sides by 2. We get cosine x is equal to 1 divided by 2, called 1/2. Okay. Now, cosine is positive in quadrants, 1 and 4. So we're looking for a quadrant 1 answer first. Okay, so we got to be thinking, 30. If I look at the 30, 60, 90 here, and you can use a unit circle too, but you don't need to. You can just look at this little simple triangle, the 30, 60, 90, and remember one basic thing from geometry, believe it or not, so katoa, make sure you know your definitions, all right? Now, the cosine is always the adjacent side divided by the hypotenuse ratio, and we know that the cosine is 60 degrees. All right, so cosine of 60 degrees is equal to 1/2. I know that. And when I say 60 degrees, I'm talking about pi third radians here. So I know one of my answers in radians is pi thirds. That's a quadrant 1 answer. And cosine is positive in quadrants 1 and 4. So when we take the inverse cosine, okay, x is always equal to the inverse cosine of whatever the ratio is here. I'm looking for an answer in quadrant 1 first, and then I get an answer in quadrant 4. Now, when you take the inverse cosine of 1/2, you're going to get pi thirds. Okay, so this gives you your quadrant 1 answer. That's what the inverse cosine gives you. And then after that, we're going to figure out how to get the quadrant 4 angle. Okay, so first, x is equal to pi thirds. As I just said, the cosine of pi thirds, or 60 degrees, is 1/2. The adjacent side divided by hypotenuse ratio, right? But the angle in quadrant 4 can be found by taking 2 pi minus your quadrant 1 angle, which is pi thirds. Okay, and that'll give you your 5 pi thirds ratio. Or excuse me, angle. So we got 2 angles here. Pi thirds and 5 pi thirds are our answers. All right, plus multiples of the period, which I'm going to say 2k pi, where k is some integer. And you guys know, if you're with me, that integers are like numbers like 0, plus or minus 1, plus or minus 2, plus or minus 3, comma, dot, dot, forever, right? So you can add 2 pi, which is the period of the function here, and get as many solutions as you want. Now, we're only concerned with answers between 0 and 2 pi, and that's why we only have 2 answers, and they are pi thirds and 5 pi thirds, okay? Only 2. And because these are both less than 2 pi. If we add 2 pi to both of these, yeah, there'd be solutions to the equation. However, we want to just, again, be in the interval from 0 to 2 pi. Okay, now graphically, why do we have 2 solutions? Why? I'm talking about solutions between 0 and 2 pi. Well, let's form a system here. And when you form a system, you take your equation, which is cosine x equals 1/2 right here. And you let the one side be the first equation, so y1, and the right side be a y2. So really what we want to do is form a system of equations, okay? y1 is your sine function. Okay, we know how, excuse me, why did I say that? Cosine function. Okay, we're dealing with cosine. Sorry. All right, and we know that's the parent. We can graph that easily. You guys have mastered that in class. And my second function is this horizontal line at 1/2. So where does this horizontal line at 1/2 intersect the cosine function? Well, we've talked about this in class, and cosine is bounded between -1 and 1. So what we want to do is start off with the range here. It's bounded between -1 and 1. And then, of course, you want to go all the way out to 2 pi, because the interval here is from 0 to 2 pi, okay, closed on the right. And then when you want to graph the cosine function, so let's do that. Cosine of 0 is 1, so this is 0, obviously. This is pi halves, and this is 3 halves pi. And then cosine of pi halves is 0, cosine of pi -1, cosine of 3 halves pi is 0, cosine of 2 pi is 1, and then you curve it, right? You curve it. No, 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 no. Okay, there you go. All right, and there's your cosine function. So the question is like where does this horizontal line at 1/2 intersect this graph? So let's draw this horizontal line, and this is y equals 1/2. It's a horizontal line, and it intersects the graph at two special places. Let's zoom in on here. So at A, right here, boom. Okay, guess what? That is your pi thirds. And guess what? That makes sense because pi thirds is less than pi halves. And then intersects at B right here. And if you go straight down, that's between 3 halves pi and 2 pi. And guess what? 5/3 pi. There's your quadrant 4 angle, right? Pi thirds is quadrant 1, and 5 pi thirds is quadrant 2. And so this angle here, all right, is 5 pi thirds, which makes sense because that's quadrant 4 between 3 halves pi and 2 pi. And pi thirds is obviously between 0 and pi halves. That's quadrant 1. And that's why this equation has two solutions in those two quadrants, because the horizontal line hits the graph at that point. It intersects that graph at that point. And so graphing the system graphically here shows you why you have not one solution, but two. All right. There we go. That's all there is to it. All right, let's check it out. This one deals with tangent now. Okay, so let's take it off to the side like we did before. All right, so let's take the root 3 times tangent of x plus 1 is equal to 0. We're going to isolate that tangent function, right? Obviously subtract 1. So root 3 times tangent of x equals -1. Divide by rad 3. So tangent of x is equal to -1 divided by rad 3. And we've seen this ratio before. This also exists on the 30, 60, 90. So let me draw it one more time here. So the hypotenuse is 2, small short side is 1. And guess what? There's the root 3, the opposite of 60. And we know on this triangle right here, tangent says is opposite divided by adjacent, that the tangent of 30 degrees, I'm just going to do some analysis first, is 1 divided by rad 3. When I say 30 degrees, I'm talking about pi 6 radians. So that's my quadrant 1 reference angle right here. And over here on the equation, it's negative. And you got to be thinking, when you take the inverse tangent, okay, of -1/3, you got to be thinking, inverse tangent's restricted from negative pi halves to pi halves, which is quadrants 1 and 4. And this is negative, right? So we're looking for a quadrant 4 answer. And then, so that's going to return not pi 6, but negative pi 6, okay? But we're looking for quadrants, tangents negative in quadrants 2 and 4. Okay, so I'm going to write those two quadrants down. Tangent's positive in quadrants 1 and 3, and it's negative in quadrants 2 and 4, so we got to figure out solutions there. All right, so the first solution in quadrant 2 can be found by taking its reference angle in quadrant 1. So, and the way you get from quadrant 1 to quadrant 2 is you take pi, all right, minus your quadrant 1 angle, which is pi 6, okay, and you get 5 pi 6. That's a quadrant 2 angle, all right? And then you want to get from quadrant, well, you can get from quadrant 2 to quadrant 4, you can get from quadrant 1 to quadrant 4. The easiest way to get from 1 to 4 is just subtract the quadrant 1 angle, your reference angle, from 2 pi. All right, so take 2 pi minus your reference angle, and you get, ooh, look at this. You get, not 5 pi 6, sorry. You get 11 pi 6. Okay, this is 12 pi 6 minus 1 6 pi. Gives you 11 6 pi, just with basic fraction techniques. All right, and those are the two solutions we're looking for from 0 to 2 pi. If I add multiples of the period, and again, the period for tangent is pi. If I add pi to these answers here, I'd be over 2 pi, okay? If I add pi to 5 6 pi, I get 11 6 pi, and add another 6 6 pi, well, that puts you at 17 6 pi, which is over 2 pi. So don't want to add multiples of the period here. We only have two solutions. But let's see why, okay? Now, when you graph tangent, you have to know the asymptotes, and that's why you had the previous mastery, see? You have to know that at negative pi halves, we have an asymptote. At pi halves, we have an asymptote. There's pi. At 3 halves pi, we have an asymptote. And I'm only going to go up to 2 pi because the domain here, we want to find all solutions, from 0 to 2 pi again. All right, so I'm going to plot my asymptotes to help me guide the function. This is what we do when we graph tangent. And we want to find solutions from 0 to 2 pi, so I have to graph actually 2 periods on this case, okay? So tangent of 0 is 0, tangent of pi force is 1, tangent of negative pi force is 1. All right, so and then you got a graph. Okay, so let's do that. Okay, here we go. Okay, there's 1 period of tangent. Now I go ahead and repeat those values. And I sketch the tangent function again. Okay, so let me plot these points. You want to plot 3 points for tangent, as you guys know in your masteries. So go ahead and do that right there. And then you draw your horizontal line again. So a horizontal line is at 1 divided by root 3. So our system looks like y is equal to tangent of x. I already drew that. That's my first function. My second function is 1 divided by rad 3. And if you don't know what that is, you just type it in your calculator. Whoops, got to get a calculator. There we go. So here we go, 1 divided by rad 3. It's about 0.6 if we round. All right, so let's just write down negative 0.6. And so you find 0.5 and you go right above it. Okay, so there's your horizontal line. Oh, that's positive. Scratch that. I'm going to draw negative. So negative 0.6 down here. Okay, so there's my function, horizontal line at negative 1 divided by rad 3, which is, I just said, 0.6, negative 0.6. Okay, so it intersects the graph. Where? Well, let's look. Let's see. Oh, you know what? We need to draw another period. All right, because we're going to go to 2 pi. So I need to graph another period here. I can just see that right there. So let me graph another period of tangent. Because guess what? This horizontal line intersects this graph too. Remember, this horizontal line is infinite. And so is the tangent function because it's called periodic. Okay, it's a periodic function. It repeats. Okay, so now if you take a look at this horizontal line intersects here at point A and here at point B. And if you go up to the x-axis right here, all right, if you're between pi halves and 3 pi halves, you're in quadrant 2. And guess what? That's 5 pi 6. And then if you go up to the x-axis between 3 halves pi and 2 pi, you're in quadrant 4, and that's 11 6 pi. 11 pi 6, and that's quadrant 4 here, quadrant 2 here. So what's going on in the graph matches what's going on algebraically. And then if you take a look at Desmos here we go. Those are the answers right there. All right, using Desmos, 5 pi 6 and 11 pi 6. Just type it in, click on the points, and you'll see what I'm talking about. And then the first one I forgot to show you. These answers right through here, pi thirds and 5 pi thirds. Well, here they are. Okay, so you just type your function in as a system, as 2 independent equations. Click on your intersection points, and it'll give you all the solutions you want. Pretty cool. Okay, we do this in class, so you should probably do that on your own too as well. Okay, last one. Here we go. We're going to take, this is the challenging one because look at this, the period's been affected. Okay, here you guys know that when b is 2, the period for sine now changes. It's 2 pi divided by whatever b is. In this case, it's 2 pi divided by 2, which is pi radians. So this thing repeats twice. Okay, it repeats twice, right, from 0 to 2 pi, which means we're going to have double the solutions from 0 to 2 pi. We talked about that in class as well. All right, so here we go. Let's take the equation 2 sine of 2x, all right, minus root 3 equals 0. And let's isolate the sine function. First of all, we add root 3. So 2 sine of 2x has got to be equal to positive root 3 when you add it. Right? Add root 3 to both sides. Divide by 2. So you get sine of 2x is equal to root 3. Divide that by 2 because you divided both sides by 2, right? Now sine's positive in 2 quadrants. Okay, it's positive in quadrants 1 and 2. So that means that when you're going to take your angle here, which is 2x right here, and you're going to take the inverse sine of your ratio, root 3 divided by 2, without a calculator, by the way, you're going to get 2 answers. You're going to get one answer, okay, in quadrant 1, and you're going to get your other answer in quadrant 2, and then you can add multiples of the period to get more answers, okay? So let's do this here. So 2x is going to be equal to what? What angle in quadrant 1? Well, let's go back to the basic triangle again. So your basic triangle, your 30, 60, 90, and it's 2, 1, rad 3, as you guys know. And we know that the sine of 60 degrees is rad 3 over 2 using SOHCAHTOA. Opposite of 60 is root 3 divided by 2 gives you rad 3 over 2. And we know that 60 degrees is pi thirds. So there's my quadrant 1 reference angle. So I just found an initial solution right there. Now, before we solve for x here, you got to find quadrant 2. Now, to get from quadrant 1 to quadrant 2, you subtract your angle from pi. So you do that first. And that's one of the key misunderstandings of this problem here, that you don't divide by 2 and then subtract from pi, which is the most common mistake made. You subtract it from pi first. So notice what I'm doing, and I get 2/3 pi. That's my quadrant 2 angle. If you look on the unit circle, okay, the sine of 2/3 pi will still give you the same ratio, root 3 over 2. Now, this is the time where you divide by 2, okay? Divide by 2, you can say divide by 2, or you can say multiply by 1/2, either one. I would suggest multiplying by 1/2 because you're dealing with fractions here, and 1/3 times 1/2 is 1/6. Okay, so you got to be good at fractions. So x here, and if you take, again, you take 1/2, okay, times 1/3, you get 1/6. Okay, that's a key little fraction thing here. So 1/2 of 1/3 is 1/6. So there's my first solution right there. All right, and I take a half of 2 pi thirds, I get 2 pi sixths. And if you can write that down, 2 pi sixths, guess what, that's pi thirds, okay? So I'm going to write down pi thirds here. Well, I'll tell you what. I better not do that. I mean, I'm teaching, so let me do it step by step. So you take a half of 2 pi thirds, you get 2 pi sixths, but you want to simplify this, plus multiples of the period, right? Which is 2k pi, because that's the, period of sine. And then we'll divide that by 2 here in a minute, where k is an integer. Oh, actually, I'm sorry. Whoa. Yeah, I'm sorry. Back up. So this is plus 2k pi up here. Okay, the period. Come on, I got to write it correctly here. 2k pi. I got to take a half of that, which means again the period now is k pi. Remember, the period has been affected. B is 2, so the new period is pi. So to get more solutions, you add multiples of pi. Okay, this is called multiples of the period. That's what this is right here. So multiples of the period. Okay, well, so let's do that. Let's add multiples of the period. So we're going to add pi here, get another answer. We're going to add pi here, get another answer. And we're going to have 4 answers. So the other 2 solutions are pi plus pi 6, which is 7/6 pi. And the other one, well, you got to reduce this, right? 2/6 pi is 1/3, really. So I should write pi thirds here. And when you add pi thirds plus pi, you get 4/3 pi. There we go. So now we have 4 solutions. Okay, 4 solutiones. Let's highlight them. So we got pi 6, pi thirds, 7 pi 6, 4 pi thirds. And so let's just list them. Okay, so we have 4 solutions. We'll see why when we graph here. All right, pi 6, all right, pi thirds. And this is not from least to greatest. This is just listing, okay? So I don't care about the order right now. And there we go. And again, the key is this. You have to add multiples of the period. That's important. Okay, you have to add multiples of the period because these equations actually, if they're unrestricted, all right, have an infinite number of solutions, and that's why what this 2k pi is about. You keep adding multiples of the period and you get more and more solutions. So let's graph and let's try to understand this thing. Okay, so my system looks like this right here, this one. So my first equation is the sine of 2x, okay, with a period of pi. My second equation is root 3 over 2. Okay, now root 3 over 2 is 1.7 divided by 2, which is about, let's see, let's check it out. I think it's around 0.8. So let's take root 3. Okay, there's root 3. Let's divide it by 2. And that's about 0.87. So 0.87, that's close enough. So 0.87, let's write that down. So the horizontal line is at 0.87. All right, so let's start sketching. Here we go. There's 1, there's -1, and we got to go out. So there's pi halves, here's pi. Oops, missed that one. 3 halves pi. We'll go out to 2 pi. The reason why you have to go out to 2 pi is because, well, guess what? Look right here. It says final solutions from 0 to 2 pi. That's why you got to do it. Now, this is going to oscillate twice. It's going to repeat twice because the period is pi. Okay, so I start here at the origin, go up to a max, back to the midline, to a minimum, back to the midline. Up to the max, to the midline, to a min, back to the midline. So here we go. So you curve it up, and it goes back down. And it goes back up. Now right there is one period. Okay? There is one period. But I want to solve all solutions from 0 to 2 pi. So, got to do it again. So here we go. There's 2 periods. So there's another period right here. Period equals pi. Then all I do is draw my horizontal line at 0.87, which is obviously a little less than 1. So there's my horizontal line, 0.87, which is rad 3 over 2. And then look at this. If you take a look at the solutions, so let's zoom here, we have 4 of them, all right? So we have 1 here, so 1 at A, 1 at B. Okay, so this one's pi 6. The next one, take a look at it, it's pi thirds. Pi thirds, as you guys know, is bigger than pi 6. And then we have 1 at C, 1 at D. And this one here is 7/6 pi. And then at D, guess what? That's your 4/3 pi. So we have 4 solutions. There we go. So this one right here, this is obviously the one you have to practice and get good at right here. Number 3, because it's the hardest one and it's on the exam, okay? And so you better study, better practice. This is an important one here because solving equations is a big deal. And you have to know when you have more solutions. And whenever B is greater than 1 and the period is compressed, it's going to repeat more times from 0 to 2 pi, and you're going to have more than 2 solutions. All right, so practice well and practice to mastery. That's why we call these masteries here. And so get your basic concepts down, and I will see you in class. Hopefully this helps you out. This is Aynesworth. I'll see you soon.